All right, let's look at this one in section 3.3, achieve number 18. Should look something similar to this. You have a constant A. A is a constant with respect to the variable in this case, which is X. And you can see that here, taking the derivative with respect to X. So let's compute this derivative here. So A is a constant. So just think A is like, a number, pick a number like 5. This is like 5x minus 3 divided by x to the fourth minus 5, for instance. Okay. But again, we're going to leave it as A. And so we're going to use the quotient rule here. I mean, this is section 3.3 now. We can use the quotient rule and the product rule. So remember, the quotient rule says you take the derivative of the top function. So I'm taking the derivative with respect to x of ax minus 3 times the bottom function, x to the fourth minus a, minus the top function times the derivative of the bottom function, x to the fourth minus a, all divided by the bottom function squared. Okay, so what is the derivative of ax minus 3? Well, first of all, the derivative of a times x. Remember, a is a constant. So what's the derivative of, say a is 5 again? What's the derivative of 5x? The answer is 5. And so the derivative of ax is just a, right? Ax is a line of slope a, right? Y equal ax would be a line of slope a. What's the derivative? It's equal to the slope of the line. In this case, it's just a. So that's simple. What's the derivative of negative 3 or 3? It's 0, right? Derivative constant. So you've got a minus 0, which is just a. So this is all just a. That's nice. Over here, derivative of x to the fourth by the power rule, bring the 4 down, subtract 1, 4x cubed. What's the derivative of a? A now is a constant like 5. So derivative of any constant is 0. So it's just 4x cubed. So now we can just simplify. A times x to the fourth minus a gives me ax to the fourth. A times a is a squared. And then here, be careful, it's minus ax times 4x cubed. So negative 4 times a is negative 4a. X times x cubed is x to the fourth. All right, so simplify that. And then here I have negative 1 times negative 3 is positive 3 times 4x cubed. 3 times 4, positive 12x cubed. So just distributing that through carefully, watch that sign. And now I just, of course, the bottom, I'm just going to leave alone. I'm not going to expand that out, just leave it factored, because if I could factor and simplify the numerator, factor the numerator, then simplify the whole expression, I would. But the only like terms are x to the fourth terms. I've got a minus 4a, right? That's a negative 3a x to the fourth, right? So just combining like terms, x to the fourth. And then I've got negative a squared and then plus 12x cubed, all divided by x to the fourth minus a quantity squared. Now, there's nothing I can really do to factor up here. I just have you note that you can rewrite this if you want to think about in terms of a polynomial, in terms of x. We usually write a lot of times in descending order. So the first term would be x to the fourth term, and then the x cubed term. So I just move that up, and then minus a squared. That's just a constant term in this case, because remember, a is a constant. So this would be the final result here. You can enter in, I think you can enter in this one as well. I don't think the order actually matters up top, but this is the result. So again, just being able to compute, keeping a as a constant, you have this expression. Now, if a were equal to 5, I can just replace a with 5 here, here, and here, and I would have the derivative for that particular function. Okay, hope this is helpful. And again, if you have questions, please let me know.